Hi guys, today we're going to be taking a look at ATDI's HTZ Warfare and some of the workflows, the automated workflows that are unlocked using HTZ's Web API. It's a fully RESTful API, and we'll talk a little bit about the advantages it brings. First of all, HTZ Warfare, it's very comprehensive electronic warfare simulation software utilized by armed forces globally, whether that's, Army, Navy, Air Force. It's able to model all tactical wireless comms. These are just some of the use cases, potential use cases that it unlocks for its end users. We're not going to go into this in detail, but you can see anything from identifying effective detection range of sensors to performing GNSS jamming simulation, modeling the performance of CRPA drones against your jamming network. So there's a whole bunch of analysis, and they can be performed with just HTZ alone. All right. What the RESTful API does allows the powerful analysis capabilities of HTZ Warfare and turns it into a near real-time simulation tool of various battlefield scenarios. You're able to design quick, customizable GUIs, which are more suited for tactical operational requirements. You can visualize connectivity for on-the-move simulations at different time intervals as well. So there's a whole host of capabilities that it unlocks. This is a use case that we're going to be looking at today. It's a classic case of using direction finders to detect and localize ground-based targets. Now, the problem in some regions is that there's way too much obstacles, and whether it's mountainous region or whether it's thick vegetation, that's limiting the coverage of ground-based direction finders. So there's a lot of innovation happening in this space. What they're starting doing is mount direction finders on top of drones and fly them around, increase the coverage so they're more successfully able to detect ground-based targets. So that's the use case that we'll be covering today. Our API engineer, Chris, is going to show you the GUI that he designed, and it's powered by HTZ Warfare.
Okay, thanks, Edmund. Okay, so this is basically the API GUI that designed. Just to note that this design is customizable. Okay, so let's start with the starting HTZ first. Okay, it's starting HTZ. Then let's load the project, call in the defense 25-meter map. Load the project. Okay, so this is the project area. And then let's have a look at stations list. So we've got dummy station, just a random dummy station, and we'll go straight to analysis. Okay, so we'll look at the on-the-move analysis. And we're going to define on-the-move object as DF. And first of all, we will need to define the on-the-move path. So we are going to upload path, speeds.
So these are the flight paths for the drones, right?
That's right. Yeah. And then you need to set your DF parameters, like on-the-move DF parameters. So let's say our DF is L-line type, and station template will just follow this DF sample. And the minimum frequency and maximum frequency for detection, let's say 100 megahertz and 500 megahertz. So after that, you need to set your DF coverage parameters. So let's just assume your target is emitting about 20 watts and frequency is 350 megahertz. And let's say they're on the ground level, so 1.5 meter height. And let's run about 30 kilometer range of DF coverage. Okay, so click run. It's going to calculate the coverage of DF of all the on-the-move waypoints. And while it's doing it, let me just show you what this CSV looks like. So one of the CSV looks like this. So as you can see, there's a waypoint 1, 2, 3, 4, 5, 6, and then there are locations with the height. So what it means is that at t equal to 0, it will be at this waypoint 1 at this location with this height, and at t equal to 1, it will go to waypoint 2 with this location and this height. and so on. Okay. So we set up the path with the CSV. Okay. And then this is basically the DF composite coverage. And this itself is not useful. So we are going to look at this analysis step. So let's look at, we want to analyze at time t equal to 0 first. Okay. So let's just generate the composite coverage of DF at t equal to 0.
I mean, it's still useful because it shows you the coverage area,
Yeah.
the range of the DF, but doesn't help us triangulate or localize.
That's right. Yeah. So at t equal to 0, there are two DFs in here, and then these are their DF coverages. So if you want to figure out where the target can be found with these two DFs, you need to look at this overlapping coverage. So let's run the analysis for overlapping coverage. And as you can see, there is a pink area, like a purplish color. So those are the overlapping area of those two DFs. And this blue area is the best suburb for this DF. And this light pink color is the best suburb for this DF. Okay. So only the targets within this pink area can be detected by those two DFs. Okay. And as you can see, even if the drones are high up, it cannot really detect many targets on the ground level due to the terrain or
they're not going to be able to localize in
That's
that
right.
area. Very limited strip.
Yeah. And let's look at the other time window. Let's say t equal to 2. Let's generate the overlapping coverage. So let's run the analysis. So t equal to 2 will be around this area. Okay. So as you can see, also t equal to 2, the overlapping area is quite minimal. As you can see, those pink area. So the targets within this area can be localized and then identified by those two DFs. Okay. So now I want to show you the more flat area. Okay. So which will be t equal to 3 this time.
So what we're doing, Chris, is we're moving along the flight path.
That's right.
Drone. Okay.
So if you look at the t equal to 3, generate the overlapping coverage. And this is a bit of flat area. So there you go. So you should expect a more overlapping area. So targets within this pink area can be detected by those two DFs. And those DFs are when time t equal to 3. The DF's location at this time. Okay. Yep. So this is basically how you analyze those on the move DFs on each waypoint with each time, and then figure out which area target can be detected on which area. Okay. So maybe it's good to show you some more advanced analysis using the HTZ Warfare, just a path profile to show you why it cannot be detected on the not pink area. Okay. So let's get the project. Let's reload this project. So this software is a HTZ Warfare. And then as you can see, we've got those DF at t equal to 3. So those are the DF composite coverage, and this is the overlapping coverage. So I'm just gonna look at the path profile from one of the point on this green area to this on the move 1 waypoint 4. Okay. So if I do the path profile from on the move 1 waypoint 4,
Where it should have coverage.
Yeah. Okay. So and as you can see, it's got pretty good line of sight with on the move waypoint 4 located on the left and right side. This is the target where I just right mouse click. Okay, that's why it's covered by this green area. Okay,
Within the coverage area. Yeah.
and then now if I do that to the other DF, path profile from now on the move 2 waypoint 4. And as you can see, the high terrain actually blocks it. That's why this DF cannot cover this area. That's why there was no overlapping coverage. Okay, so that's the reason why the the area was colored by green, not the pink, brown. Okay?
Come back to the GUI.
Yep.
Yeah. So guys, this is just a type of analysis that can be performed. And so the Web API allows us to sort of design this configurable GUI that allows us to simulate the flight path of the drones at different points in time, display the coverage, display the overlapping coverage. So we're able to analyze the effective localization zones of these ground-based targets. Now, some of the insights that can be generated, you can see that some areas, particularly at the start of the flight, right, they don't have enough overlapping coverage. So you probably need to increase your altitude, increase the height of the drones, right, and to be flying higher to produce more overlapping coverage. So this is just the type of analysis that can be unblocked. But yeah, unless there's anything else, I think it's a really good use case.
Yep, that's right. And thank you for your time.
Okay.